All right, guys, welcome back. This is lesson 5.6 about integration by parts. This is for BC only. The AB class does not need to learn this. You may want to learn an AB, though, to help you have another method for taking integrals. So let's get cooking, talking about integration by parts. So for an integral like this, when we look at this integral, if we try to use any of the methods we already know, so like we try to use substitution, it's not going to work. Because if I tried to make u like 6x right here, then du would be 6dx. I can't substitute that in because I still have an x right here. I'd be trying to integrate something that has an x involved. So instead, we're going to have to use integration by parts. Sometimes you might hear this as u dv substitution, because what we do here is if I take the integral of u times dv, it's going to be uv minus the integral of v du. I'm going to show you how this works in just a second, but it's going to be kind of similar to u substitution. But instead of just picking u here, we're going to have to pick something for u, and we're going to have to pick something for dv. Occasionally, when we do this, when we identify u and dv from the original function, we might still be left with something that we can't integrate, which means we're going to have to go back and try again. So that is probably, honestly, the most frustrating part of this. So when learning integration by parts, this method right here, courtesy of Mr. Poor at Eastside, is the Lipid Method. And it's a method for helping you figure out what to choose for u. And whatever you choose for u, everything else in the integral is dv. So the first thing you're going to look for is logarithmic functions. If you don't have any of those, you're going to look for inverse trig functions. If you don't have any of those, look for polynomials, and then exponential, and then trig functions. So starting from L, working to T, this is not a foolproof 100% will work method, but it is a method that will help you while you're learning integration by parts. So let's take a look at the integral that we were looking at. So the integral of x times e to the 6x dx. What I need to pick is I need to pick something for u, and I need to pick something for dv. So I'm going to look for logarithmic. Don't have anything logarithmic. I'm going to look for inverse trig. Don't have any inverse trig. I'm going to look for polynomials. I do have a polynomial. So what I'm going to do is I'm going to let u be this polynomial x, which in that case means that du is dx. All right, and then if x is u, then dv is e to the 6x dx, which means v, I forgot to write v. So if I integrate what I have right here, so if I integrate this, v would be 1/6 e to the 6x. All right. So the reason I do this is because if I have the integral of u dv, that's equal to u times v. So this would be x over 6 times e to the 6x, that's u times v, minus the integral of v, which is 1/6 e to the 6x, du, and du is dx. And I can take this integral now. So this is x over 6 e to the 6x minus, and then when I integrate this, this would be 1/36 e to the 6x, and then plus c. So then this would be my integral. If you're not sure, you could take the derivative of this, see if you end up with x times e to the 6x. Spoiler alert, you do. All right, so that's an example of integration by parts. I'm going to leave this example here for you to try. We'll do this in class as well. Actually, in 2021, we've already done this in class. But this is another place for you, or another example that you can try to work. And so today, we just talked about integration by parts. If you want some practice, this website, Paul's Online Math Notes, a lot of credit to this guy. He does a lot of fantastic work. If you go into Paul's Online Math Notes in the Calc 2 portion, integration by parts, he has some fantastic practice problems with very detailed solutions to help you walk through the solution one step at a time. So if you have any questions, bring them to class. If you need some practice, you can go here and get some practice. If you want more practice, email me, let me know. But you guys have a fantastic day. I'll see you in the next video.